In a previous lesson, we learned that when we can take a quadratic and write it in factored form, those factors give us a lot of information. They tell us where it hits the x-axis, which is the solutions. It just gives us a lot of good information. So what we're going to work on in this lesson is taking a quadratic and actually factoring it. Now it says you know from FOIL that, and it gives you all these information here. Basically, here's what it means. If I look at this example right here, x plus 4 times x plus 2. If I wanted to use FOIL, I'd go my first terms, x times x, which is x squared. My outside terms, which is 2x. My inside terms, which is 4x, not 8, 4x. And my last terms, which is 8. Now let's look at this just for a second. We know it's going to simplify down to this right here. So if I want to take this and factor it out into these two things here, notice I multiply my last terms to give me 8. So what you're going to be looking for is you're going to be looking for two terms that multiply to give you the last term. Okay. Basically multiply, you're looking for two numbers that multiply to give you 8. But then look here in the middle, we have 2x and 4x. That equals our 6x. We're also looking for two terms that add to 6x. And that's what this means here. We are looking for multiply to give you your c, two terms. You multiply for c. And two terms we add for b. Now again, I know that seems confusing as soon as we start talking about variables, but this is what we're doing. In this example here, we're looking for two numbers that multiply to give you 8 and add to give you 6. 4 and 2. 4 times 2 is 8, 4 plus 2 is 6. So that's what we're going to be doing when we're factoring. We're going to be given the quadratic and we're going to break it down into its factors. Looking for two terms that multiply to give you your last term here, your c, in standard form, but also add to give you your b term. Okay, let's try some examples. It says factor x squared plus 8x plus 15. Where you want to start is you look here at the 15. Let's think of two numbers that multiply to give us 15. We have 1 and 15. 2, no. Yep, 3 times 5, 4, no. Okay, so these are our factors. They have to multiply to give us 15, but add to give us 8. That's what we said right here. Multiply to give us our c, add to give us our b. 3 and 5 do, right? So basically, what we're doing is, since it's positive and positive, we know that both of these are going to be positive. We know that they have to multiply to give you 15. Well, 3 and 5 do. Do 3 and 5 add to 8? Yeah, they do. Now, will all of them be that easy? No. But this is kind of the basic idea. If you want to make sure you did it right, use FOIL. First, outside, inside, last. X squared plus 5x plus 3x is 8x plus 15. Two terms that multiply to give you the last term, add to give you the middle term. This is in factored form. Remember, when it's in factored form, if we set it equal to 0, we know our solutions, we know our x-intercepts. Let's look at another example. Factor x squared minus 9x plus 20. Now, when we go to do this one, notice it's a minus here and a plus here. We're multiplying to get 20. If we're multiplying to get a positive 20, we have two choices. They're either both positive or they're both negative. Since this has to be a negative here, the only way we can get that is if they're both negative. So I kind of set it up like this. I'm going to plug in two numbers. I know they're both negative because this times this has to give me a positive 20. Now if you need to, make a t-chart. 1 times 20, 2 times 10, 3, no, 4 times 5. It's a little tricky because they have to multiply to give you 20 and add to give you a negative 9. But we know they're both negative, so you can kind of just think that all of these are negative. Can I add negative 1 and negative 20 to give you negative 9? No. Can I add negative 2 and negative 10? No. Can I add a negative 4 and a negative 5? Yes. So this has to be 4 and 5 because I already had the minuses there. Negative 4 times a negative 5 is positive 20. Negative 4 plus a negative 5 is negative 9. Again, use FOIL. First, outside, inside, last. Middle two terms are your like terms, and we get our exact solution. So when you see that it's going to be a negative before your b term here, and this is positive, negative times negative is positive, so you know they both have to be negative. Let's try another example. Factor x squared minus 8x minus 9. Now notice in this situation they're both negative. The only way we can multiply two numbers to give us a negative 9 is if one's positive and one is negative. This is where it can get a little tricky. One has to be positive, one has to be negative. They have to add to give you a negative 8. So what we're doing is we're looking for two values that multiply to give us a negative 9, but add to give us 8. So let's just look at our factors of 9 here. 1 times 9 and, well, 3 times 3. Both of them multiply to give us a negative 9. This would be negative, or this would be negative, this would be negative, or this would be negative. But what can add to give us a negative 8? Well, we know it's going to be in a 1 and a 9 here. Okay, but which goes where? Sometimes, and you'll get better at this, sometimes you just have to guess and check. So if I put in 1 here and 9 here, maybe say that this is negative and this is positive. First is x squared, outside is 9x, inside is a negative 1x, last is negative 9. So I got my negative 9. Sorry, there should be an x there. But now if I add my middle two terms together, 9x minus 1x is 8x. Did I want a positive 8? No. So we know it can't go this way. So probably it's going to go the other way. X plus 1, x minus 9. That can be tricky, but the more you work with it, the easier that is to see. Checking real quick. X squared, outside is a negative 9x, inside's 1x, and then we have our negative 9. In this case, we get our negative 8x minus 9. So our solution is x plus 1 times x minus 9. Okay? All right, one more example. In this case, it says factor x squared plus 3x minus 18. This is positive and this is negative. So, again, I always kind of write this out. I can't tell if they both aren't going to be negative or positive. It's going to be a mixture because multiplying to give me negative 18, one has to be positive, one has to be negative. The more you do this, the more you'll be able to just see the numbers without having to write all this down. Just takes practice. Okay, so I look at all those combinations there. I'm looking for which pair that I can multiply to give me negative 18, but it's going to add to give me a positive 3. Multiply to give me 18, I can't see a way of making either of these negative to give me this adding to get a negative 3. I'm sorry, positive 3. I can multiply 2 and 9 to get a negative 18, making one of them negative. But I can't think of a combination where I can add either a negative 2 plus 9 or positive 2 plus a negative 9 to give me 3. But I think that will work for 3 and 6. Excuse me for 1 second. Okay, sorry about that. I know that my two factors are going to be 3 and 6. What I have to decide is which one's positive and which one is negative. If you can't see it, some of you might be able to see, hey, I need this to be a positive 3, so I'm going to make my bigger term positive. That's fine. If you can't, just guess and check. I'm going to make this negative and this positive. Okay? Using FOIL. I get my negative 18. And then when I combined it, 6x's plus 3x's, you get 3x minus 18, which is what I wanted. If I weren't to get that, then maybe you just got to switch the plus and minus sign around. Okay, again, when a quadratic is written in factored form, it gives us lots of good information. It makes it easier to graph. It makes it easier to find the solutions. Unfortunately, as you're going to see later, not every quadratic can be written in factored form. And learning how to put things in factors really just takes practice. You need to see the number relations, and the more you practice it, the better you'll get.